All right, let's talk about something that could totally change the game for how you work with data in Python. Imagine, what if you could take a super high-performance, multi-model database and just embed it directly into your code? What if you could get rid of all that network latency that slows down so many AI applications? Well, that's exactly what we're diving into today.
So first up, let's set the stage with a challenge that, honestly, if you're a Python developer, you probably face every single day. You've got your brilliant code, your clever models, all your logic living in one place. But the data, the fuel for all of it, yeah, that's usually living somewhere else entirely.
And, it's a really simple question, right? But it points to this massive, everyday frustration. This separation between your application and your database creates this gap. And that gap isn't just about distance. It's filled with latency, with complexity, and, let's be honest, a whole lot of potential points of failure.
So this really shows the two worlds we're talking about. On one side, you've got the standard way of doing things. Your Python code has to make what's called a network hop to go talk to a separate database server. That little round trip, that's a huge source of slowdowns and operational headaches. But the approach on the other side, well, that's an embedded engine. The data lives right there with your code. That expensive trip across the network, it's just gone.
So how do we get from one side to the other? How do we close that gap? Well, that's where this really elegant solution from HumanEye comes in, all built on the open source ArcadeDB. Think of it as a direct, private highway for your data, designed to completely eliminate that network hop.
The actual tech is called embedded Python bindings. And here's the crucial part. Instead of your Python code talking over a network to a database, this lets your code talk directly to the database engine itself. It's just a super thin layer that lets Python communicate straight with the core Java engine, all happening inside the very same process.
And this whole approach is built on three really powerful ideas. First, you get embedded access for crazy low latency, which is just perfect for local development or any high-performance job. Second, it has a Python-first API, so it feels completely natural and intuitive for any Python dev. And third, it's all self-contained, which makes getting set up an absolute breeze. And when we say self-contained, we are not kidding. The entire package, the thing you actually install, is only about 116 megabytes. Now, what's so incredible about that is it includes everything you need, even its own lightweight bundled Java environment. You don't need to go install Java yourself. You literally just pip install it, and you are ready to rock.
Okay, so you've got this tiny zero-latency database engine running right inside your Python process. Awesome. But what can you actually do with it? Well, this is where things get really cool, because this is where ArcadeDB's power as a multi-model powerhouse really starts to shine. You get 3 different data models in one engine.
First up, you get your classics, support for tables and documents. You can set up your schema with a few simple Python methods, and then query it all using the standard SQL that you already know and love. It's familiar, it's powerful, and because there's no network in the way, it is unbelievably fast. Second, you get a full-blown graph database. This is perfect for modeling really complex, interconnected data. Think social networks, or maybe the memory for an AI agent. And while it supports standard languages like OpenCipher, honestly, that Python-first API is often the simplest and fastest way to work with all those tricky relationships. And third, and this is a huge one for AI right now, is vector search. You can build and query high-performance HNSW vector indexes, which is just a fancy, super efficient way to find the nearest neighbors in massive datasets. This means you get lightning-fast similarity searches for things like retrieval augmented generation, or RAG, all without ever having to leave your local machine.
Okay, so we've got these 3 powerful models, tables, graphs, and vectors, all sitting together in one embedded engine. That's great, but let's connect this back to the real world. What does this actually mean for the problems you and I are trying to solve every day?
This really shows you the why. That powerful graph model, well, that's perfect for building those sophisticated memory graphs for AI agents. That built-in vector search, that directly powers your RAG pipelines. The fact that it's all local and embedded, that means your dev environment can finally be a perfect mirror of production. And the self-contained engine lets you run serious analytics without having to spin up a whole separate database server. It just works.
So what's the big takeaway here? What's the one thing you should remember from all this? This is about more than just a cool new library. It's really a shift toward a local-first way of thinking about your data.
The creators over at HumanAI really said it best. The goal is simple. Improve latency by just getting rid of the network. Reduce all that operational overhead because you don't need a separate server. And ultimately make it way easier to build, test, and ship reliable AI applications.
So, to wrap it all up, here are the keys. 1. You get incredibly low-latency data access right where your code is. 2. You get this unique power to combine structured graph data with speedy vector search, all in one place. And 3. You get to work with a truly standalone, self-contained tool that just simplifies your entire workflow.
And that kind of leaves us with one final thought. For so long, we've had to design our applications around the fact that network latency is just a thing we have to deal with. So I'll leave you with this question for your next project. What new doors open up? What will you build when your database has absolutely zero latency? Thanks for tuning in.